Welcome to a screencast on setting up chromatography, and we're going to be using this to separate some plant pigments here. So chromatography, first and foremost, is a separation technique. So if things are in a mixture and you want to separate them out, chromatography is a way to do that. And this is the first of a couple of different separation techniques that we're going to see in class this year. So we have here, in this case, a mixture of pigments that are contained in the leaf, and we want to see if we can separate them out. So now you know that leaves are green because of chlorophyll. But then you also know that recently, in the past couple of weeks, the leaves have been turning different colors. Really, it has not been due to them turning colors, but rather the chlorophyll color kind of going away, breaking down, and then revealing that there are other colors underneath that. So some of the colors, the carotenoids, right, which are yellows and oranges, xanthophylls, right, are another group. Anthocyanins are yet another group. Okay, so just the different colors that you see out there are because of the different pigments. So we want to see if we can take a leaf and see if we can separate these pigments. Now the separation is going to be based on their chemical characteristics, right? Primarily polarity. Right? Right? So what's going to happen is that the pigments will dissolve in a solvent. So we're going to get these pigments to dissolve in a solvent, and those solvents are typically organics and organic solvents such as, for example, acetone. Right? This is also the chemical that's in nail polish remover. So that's what's going on there. You're dissolving the pigment, the nail polish, to get it off of your nails, provided, of course, that you paint your nails. But dissolve those pigments in a solvent, and then we move that solution, right, over what is known as a stationary phase. So the solution is known as the mobile phase. This is the mobile phase. And then the stationary phase is going to be something like paper. And what's happening is the pigments are going to have a different affinity for the paper. And so as the mobile phase moves across the paper, the pigments will adhere or adsorb to the paper at different levels, and you'll be able to then separate them out. So this is what we see in the image right here. So this is a strip of paper. You want to try to just hold the paper by the edges, and the paper is the white, and this is just the background, the black. So you want to try to hold the paper by the edges, not to put your fingerprints all over, here and here and here, because the oils in your hands will actually smudge that a little bit, or will affect the mobile phase. So the first thing you want to do is get a ruler and a pencil, and you're going to measure from the bottom, or sorry, across the middle here. Put a point right in the middle, and then measure a point 2 centimeters up, and then 2 centimeters up from the bottom there, and then draw a line across with the pencil. Then connect the point there and the point there to draw a little triangle, and then you're going to cut this edge off and cut this edge off so that you have sort of an arrow piece of paper there. Then you're going to take a leaf, and here I just went outside and grabbed a sycamore leaf here, and you're going to lay the leaf over top of where that line would be, so you'll be able to kind of see like the line on the paper was right about there. Right? And then you're going to take a quarter here, and a quarter because it's got the ridged edges there, and then with some pressure roll that quarter back and forth, and when you do that, you'll see right here that you sort of depress and you leave some of the pigments right here on that line, or as close to the line as you can. If you don't get it exactly on there, that's not the end of the world. You want to try to do that. I did it a couple times, 2, 3 times here. The more pigment you get laid down on that line, and you don't get any pigment sort of smudged all up in here or anything like that, the better your chromatograph is going to be. So you want to try to get as much pigment as you can right there without ripping the paper, and etc. So if you do that, you're just going to have to get yourself another piece of paper and cut through it then. So you got your pigment on there. Don't know why I have an up-close version of that. I was rushing here, so it doesn't go all the way across. That's okay, it's not the end of the world, but you want to try to get this whole thing loaded up with pigment, right, all the way across there. And again, the more pigment you get on there, the better results you're going to have. Then you're going to have a test tube with a cork in it here, and it's sitting in a test tube rack. And down here is the organic solvent. And we are using petroleum ether and acetone as our organic solvent. This stuff is extremely flammable. It has a low flash point, and it's going to evaporate very, very quickly. So you'll come back to the fume hood, and I will help you get the organic solvent into your test tube, and then you want to definitely cork it right away. Right? You do not want to be wafting this. You don't want to be smelling this because it's ether, and that'll knock you out. Right? So we are not doing that. The next step then is to uncork it and put the piece of paper with your pigment down into there. Now you see that just the tip of the paper, right? Just the tip of the paper is in the organic solvent here. And you can see that the solvent is beginning to move up. Right? This is the wet line right here. The solvent is moving up via capillary action, this paper. You do not want to get the pigment down into the organic solvent. You want to let the solvent, remember, this solvent is the mobile phase. The mobile phase is going to move up over the pigment here. And as it does so, it will dissolve the pigments, and then this is going to continue traveling up, this mobile phase. So this solvent is going to continue traveling up, and as it does so, it's going to bring the pigments that are dissolved in that solvent along with it. Now again, I was rushing here and to get this done, so this is not developed all the way, meaning that you don't see any pigments laid out here. But what you hopefully should see is some different colors, right, along here that have separated out. Right? So they've moved up this way, and you'll know that you're done running this because when the solvent gets to up here, we call this the solvent front. That's the solvent front, and then this would be pigment 1, right? This would be pigment 2. This would be pigment 3. This is how far the pigments traveled, and then here's pigment 4, say. And so this then is the starting, right, part. So now these pigments have moved, and each of them has its own characteristic RF value, and this is described in the pre-lab. So the RF value, you can calculate this. It's a ratio, a proportion here of the distance that the pigment moved from the start divided by the distance that the solvent front moved. Right? And there's no unit. It's just going to be a value, something less than 1. Okay? So the way you would do that is you take a ruler after this is done. After this is done developing, let me back up a second. After this is done developing, you'll uncork it, take the paper out, recork it, and then let it dry. As soon as you pull this out, the solvent front is going to kind of evaporate and disappear. So as soon as you pull that out, you want to mark with a pencil where that solvent front was. And so I'll say that again. When the solvent front gets to the top of the paper here, that's when you'll know to uncork it. So you uncork it, take the paper out, recork that very quickly with a pencil. Right? Actually, probably even before you recork that, with a pencil, draw where that solvent front ended. Right? Then you're going to take a ruler, measure from here all the way up to the solvent front. That's how you know the distance. Right? And then you would measure from the start to there, and then measure from the start to pigment 3, and so on and so forth. Right? and then do the math, and you're going to calculate then RF values for that. Okay? And then the different pigments have different RF values associated with them, and in the lab there it describes maybe which ones are which. So, all right, see you in the lab.